going to review how to solve applications involving quadratic equations. So the first type we're going to talk about is a projectile motion problem. A projectile is any object that is thrown, shot, or dropped. The formula down here, h of t equals negative 16t squared plus v naught t plus h naught gives you the formula to help you find the height of the object at any given time. So t stands for time. H of t here is that height at any time. This v naught is your initial velocity, so how quickly is it being thrown or shot up into the air? And then h naught is how high is it starting. Okay, so we're going to use that. When you take your test, the equation will already be given to you. On some of your homework problems, you actually have to plug those in to come up with the function first before you can answer the questions. So for the first problem here, a frog jumps straight up from the ground. The quadratic function h of t equals negative 16t squared plus 12t models the frog's height in feet above the ground after t seconds. What is the frog's maximum height? How long does it take to get there? And about how long is the frog in the air? So we really have 3 questions there, but the first 2 questions can actually be answered by thinking about the maximum. Remember, the maximum of a function is at the top of the graph. And when we're looking at parabolas, that's our vertex. So to find the maximum or the vertex, we use the opposite of b over 2a. So for this function, we're going to do negative 12 divided by 2 times negative 16. If we simplify that, 12 divided by 32 gives us 0.375. And this is seconds. So that's actually the answer to the second question. How long does it take to get to the maximum height? To find the answer to the first question, we're going to take the answer and plug it into the function. So we're going to do h of t. So we're going to do negative 16 times 0.375 squared plus 12 times 0.375. Okay, and I'm just going to plug that directly into my calculator. And that gives me 2.25. So if I had to summarize the first 2 answers, I would say the frog reaches maximum height of 2.25 feet at 0.375 seconds. Okay, so this answers the first 2 questions. Okay. The second part of the problem has to do with how long the frog is in the air. Okay, so that's our third question here. To figure out how long something is in the air, we need to think about how high something is when it's not in the air. When it hits the ground, it's at 0. So we're going to actually take the function and replace h of t with 0. We want to figure out when the height is 0. Okay, I can either use the quadratic formula or I can factor. For this case, I'm going to factor because I can divide each of those by negative 4t. So you get positive 4t minus 3 equals 0. And then to solve, I'm going to set each part equal to 0. So negative 4t equals 0, and 4t minus 3 equals 0. We're going to divide by negative 4 on both sides, and add 3 to both sides, where we divide by positive 4. So for the first one, we get t equals 0. Okay? Now if you think about that, when time is 0, he's starting on the ground before he jumps. So that makes sense. Starting at a height of 0, when time is 0. And then he's going to hit the ground again at 0.75 seconds. Okay, so that's the answer to the third question. Let's look at the next problem. Okay, for this one, we're given a lot of information, but not a function to start. So a baseball is thrown with a vertical velocity of 48 feet per second from an initial height of 5 feet. Write the function to model the height in feet of the baseball, where t is the time in seconds since the ball was thrown. Find the maximum height that the ball reaches and approximately how many seconds it takes the ball to reach that height. Okay, so this is, again, that first question. Maximum height and how long it takes to get there. Okay, and then find how many seconds the ball takes to hit the ground. So that's the second part. Okay, before we can do any of that, we need to use our initial vertical velocity and our initial height to write the function. So we're going to have h of t equals negative 16t squared plus 48t plus 5. Now, you can go ahead and do this one by hand. You can do the opposite of e over 2a and plug it in to find the height. So that'll give you the answer for the ones that are underlined in red, how long it takes to get to the maximum height, what the maximum height would be. And then you can set it equal to 0 and use the quadratic formula, or you can use a graphing calculator. So I'm going to show you how to go ahead and use the graphing calculator right now. So our equation is 16t squared plus 48t plus 5. So I'm going to go to my graphing calculator here and type that in, my y equals. So notice I hit y equals. We have negative 16, we're going to use x squared plus 48x plus 5. Okay, I'm going to go ahead and hit zoom 6 just to kind of have a standard window. And when I do that, you'll notice that on my graph, I can't see the maximum height. So I'm going to go ahead and change my window by hitting the window key. And I want to change my maximum height so it goes a little bit higher and I can see more. So I'm going to put that up to 50 and go by 5s. So I change my y-max to 50 and my scale to 5. I'm going to go ahead and graph that again. Now you can see the nice parabola. So remember, if we're finding the maximum height and the time it takes to get there, we need to find our maximum, or our vertex. So we're going to do second trace, and then hit option 4, because we're looking at our maximum. On this screen is going to ask you 3 questions: left bound, right bound, and guess. Left bound means tell me something that's on the left side of the maximum. Right bound, I'm looking for something on the right side. And guess doesn't really matter, you can just hit enter. So on the left, I'm going to use 0. And on the right, I can tell that my maximum is somewhere around 2, but I'm going to use 5. So I hit 0, enter for my left bound. I'm going to use 5 and hit enter for my right bound. Then I'm going to go ahead and hit enter again for my guess. Once I do that, at the very bottom of the screen, it says maximum. X equals 1.5, y equals 41. So let's write that down. We just found that our maximum is 1.5, 41. We're going to come back to that. Okay, that's actually the answer for the first 2 questions. The next thing we're going to do is answer the second question. With this same graph, we're going to go ahead and calculate our zeros. So we want to find out when the height is 0. We're going to do second trace again. This time we want to know when it's 0, so we're going to hit option 2. They're going to ask the same 3 questions, so left bound, right bound, guess. So I'm going to use 0, enter for left bound. That's my left side. I'm going to use 5 for my right side, enter. And then guess, I'm just going to hit enter, it doesn't matter. And I find my 0 is 3.10. Okay, so we're going to go ahead and write that down. 3.10. Okay, I'm going to flip back to that for a second, just to make sure you saw it. At the very bottom, 0 is 3.1, comma, 0. So we just found our x-intercept and our vertex. Those are the 2 things we need to be able to answer these questions. So now that we have those, we're going to summarize, because I like to have labels. The baseball has a maximum height of 41. Change that, of 41 feet at 1.5 seconds. Okay, and then for the second one, when I found the 0, this is telling me it takes 3.1 seconds to hit the ground. So for the projectile motion problems, you can use either negative b over 2a to find your vertex, and then also factor or use the quadratic formula to find your 0, or you can use the graphing calculator. Go ahead and try the next 2 problems, and if you have questions, see Mrs. Wolf.